In this video, we're going over the concepts of Chapter 7, which is titled Chemical Quantities and Reactions. In this chapter, we are going to start by looking at equations for chemical reactions. Chemical reactions are another word that we can utilize for chemical change. The definition of a chemical change is that a substance is going to be converted into one or more substances with different chemical formulas and different chemical and physical properties. There are indicators that a chemical reaction or a chemical change has occurred. And we can see on the right side of the slide that those are illustrated. They include a color change, the formation of a solid in a previously clear, in other words, unclouded solution. And the formation of that solid is called a precipitate. The formation of a gas when a substance is added to the solution. And we can observe that because a gas is forming, bubbles may appear as the gas is trying to escape the liquid phase. The emission of light, and lastly, emission or absorption of heat. These chemical reactions or chemical changes are illustrated via a chemical equation. The symbols that are utilized for these chemical equations are summarized in table 7.4. Let's see how they're utilized in order to represent a chemical reaction. First, let's understand that there are two parts to a chemical equation: the substances on the left and the substances on the right. Any substance that is on the left of the arrow, that is known as a reactant. You can have one or more reactants. Every time you have more than one reactant, it is separated by a plus sign. Any substance that is to the right of the arrow is called a product. You can have one or more products, and in the case that you have multiple products, they're separated by that plus sign. Let's say that during the process of a chemical change occurring, the reactants are heated. We symbolize that by putting a triangle, in other words, the symbol of delta, on top of the arrow. Lastly, the other thing that can be included in a chemical equation is going to be the state of matter for each of the components in the reaction. These symbols are placed on the bottom right corner of the chemical formula for a substance. If you put an S in parentheses, that illustrates a solid. L in parentheses is a liquid. G in parentheses is a gas. And lastly, we have aqueous, which is symbolized by the letters AQ. Aqueous means that this is a water solution, meaning that the substance was diluted or placed in water in order to be utilized in a chemical reaction. There are different types of reactions. And in this course, you guys need to know the main 5 different types of reactions. Let's go through them one by one and also discuss examples for them. Let's first start by discussing combination reactions. In a combination reaction, we're going to have 2 or more reactants that when they are combined, they're going to yield a single product. As an example here, we have solid calcium combining with chlorine gas, forming solid calcium chloride. Next, we have decompositions. And when it comes to decomposition, This is going to be the opposite of combination. We're going to have a single reactant split into two or more products. We can observe here that we have solid iron 3 sulfide decomposing to make solid iron and solid sulfur. Next, we have the replacement or displacement reactions. First, we have a single replacement reaction. In a single replacement reaction, we're going to have one element replace another element. Typically, what we observe is that we have a single element and then we have a compound. And one of the two components of the compounds is what gets replaced or displaced. In the example that we have here, we have copper reacting with silver nitrate, and we can observe in the product that silver was replaced or displaced, and then you form a brand new ionic compound, which is copper 2 nitrate. In a double replacement reaction, what happens is that we're going to have two different ionic compounds, and we are going to have two elements, in other words, two components of these ionic compounds to be replacing each other. What this means is that there's actually an exchange of partners in the reactions. Let me illustrate. Since it's understood that in a double replacement reaction, the two different components, A, B, and C, D, are going to be ionic compounds, we can break them into ions, where A represents a cation, B represents an anion, C represents a cation, D represents an anion. What happens overall is that the cation of the first ionic compound forms a new ionic compound with the anion of the second. That's why here you see AD combining. Next, the cation of the second ionic compound combines with the anion of the first. And that's why we see a brand new ionic compound formed by C and B. We can observe in the example how we have barium chloride reacting with potassium sulfate. Let me break them into ions so we can observe what occurs. When I break into ions, barium chloride is going to show barium 2 plus, chloride 1 minus, potassium 1 plus, sulfate 2 minus. Here we have the barium and the sulfate combining to make barium sulfate. And next, we have K plus combining with Cl minus to make KCl. In chapter 9, we are going to explore how can we define what makes the product a solid or aqueous. The last type of reaction that we have here is a combustion reaction. And when it comes to a combustion reaction, understand that combustion reactions simply describe when a substance is reacting with O2. Now, it happens to be that if you are reacting O2, in other words, oxygen gas, with a compound that has carbon and hydrogen, or with a compound that has carbon, hydrogen, and oxygen in its chemical formula, then the products of the reaction is going to be CO2 gas, water in gas form, and energy. But at the base of the definition, a combustion reaction is going to be any substance that reacts with O2 gas. I would like to point out that every time we are reacting with O2 and it says that it is in gas form, is because we are referring to the elemental form of oxygen, which is going to be a diatomic oxygen. Remember that this is true for any of the diatomic molecules. Let's now practice classifying the different types of reactions if examples are given to us. I'm going to do letter A and B for you guys. On letter A, we have H2 gas, we have bromine liquid combining into a single product, which is called HBr. This means that this is an example of a combination reaction. Next, we have HGNO3 and NaCl. These are two compounds that are ionic, and I can see that in the product, there was an exchange of partners in the products. So this suggests that this is a double replacement reaction. Now take a moment and practice by doing C, D, and E.